Welcome to this video on charge, current, and potential difference. This guide will help you master the essential equations of electricity for your GCSE Physics exams with clear explanations and useful tips. In this video, we will cover four main areas: electric charge, current, potential difference, and some essential exam skills like rearranging equations and using the correct units. First, what is electric charge? It is a fundamental property of matter carried by electrons in a circuit. It is symbolized by the letter Q and measured in coulombs, abbreviated as C. Here is a quick summary for your revision. The symbol for charge is Q, measured in coulombs. Charge is carried by electrons and only flows when you have a complete circuit. Moving on to current, it is defined as the rate of flow of charge. It tells us how much charge passes a point every second. Current is symbolized by I and measured in amperes, or amps. The relationship between charge, current, and time is given by the equation Q equals I times T. Remember, Q is charge in coulombs, I is current in amps, and T is time in seconds. Units are vital in exams. Charge is in coulombs, current in amperes, and time in seconds. If an exam question gives you time in minutes, always multiply by 60 first. Let's look at an example. If a current of 3 amps flows for 10 seconds, calculate the charge. Using our equation, 3 times 10 gives us 30 coulombs. If you need to find current, you rearrange the equation to current equals charge divided by time. For instance, if 60 coulombs flows in 20 seconds, the current is 3 amps. To find the time taken, you divide the charge by the current. If 50 coulombs of charge is transferred by a 2-amp current, it will take 25 seconds. A useful tool is the formula triangle. By covering the quantity you want to find, you can see whether you need to multiply or divide to solve the equation. Remember that charge only flows in a complete circuit. If there is a break, such as an open switch or a damaged wire, the flow stops and the current becomes zero. Closed circuits allow current to flow normally. In an open circuit, the flow stops. A short circuit, however, is dangerous, as it creates an unintended path, potentially causing damage. Now let's look at potential difference. Once you understand charge and current, you need to understand what drives the charge through the circuit. Potential difference, often called voltage, is the energy transferred per unit of charge. It is symbolized by V and measured in volts. It essentially provides the push needed for current to flow. Let's review the key facts about potential difference. It is supplied by cells and batteries, measured in volts using a voltmeter, and represents the energy transferred by charge. The relationship between potential difference, energy, and charge is defined by this equation. Potential difference equals energy divided by charge. Remember to use the correct units. When learning units, think of the equation as volts equals joules per coulomb. This means that 1 volt corresponds to 1 joule of energy transferred per coulomb of charge. Here is a worked example. If 5 coulombs pass through a bulb transferring 60 joules of energy, the potential difference is 60 divided by 5, which is 12 volts. You can also rearrange this equation to find energy. If you have 6 volts driving 4 coulombs, the total energy transferred is 6 multiplied by 4, totaling 24 joules. To find charge, rearrange the equation to charge equals energy divided by potential difference. For example, 120 joules at 12 volts results in a charge flow of 10 coulombs. The formula triangle is a great way to quickly rearrange these equations during an exam. Just cover the quantity you need to calculate to see your next step. A cell or battery acts as your energy source. It uses chemical energy to do work on charges, giving them the electrical potential energy they carry through the circuit. This energy chain is fundamental. Chemical energy in the cell is converted to electrical energy, which is then transferred as light, heat, or motion in components. The specific form of energy transfer depends on the component. Bulbs convert energy to light, resistors to thermal energy, and motors to kinetic energy. Remember, a higher potential difference means more energy is transferred per coulomb. It is helpful to think of this like a waterfall's height, increasing its potential energy. Voltage varies widely. A small AA battery provides 1.5 volts, while UK mains electricity delivers a significant 230 volts, transferring much more energy per coulomb. Keep both the charge equation and the potential difference equation ready for your exam. Knowing how to apply these two formulas is key to solving circuit problems. Review this reference table to ensure you are comfortable with all symbols and units. Examiners expect you to be precise with these standard physical quantities. To wrap up, remember this 4-step process for every calculation. Write the equation, identify the unknown, rearrange if needed, and finally substitute and calculate. Good luck! A common mistake in physics exams is using the wrong units for time. If a question gives you a duration in minutes, you must convert it into seconds before calculating charge to get the correct answer. Follow these exam tips. Always identify your known values first, choose the correct equation, convert your units to standard SI form, and never forget to include the unit in your final answer. For multi-step problems, you may need to link equations. First, find the charge using current and time. Then, use that charge value in your second equation to calculate the energy transferred. Here is a quick summary of essential definitions. Current is the charge flowing per second, while potential difference is the energy transferred per unit charge. Always show you're working to gain method marks. Test yourself with these 4 practice questions. Pause the video and attempt to calculate the answers for each, remembering to use the correct units for each step. Here are the solutions to those practice questions. Always award yourself 1 mark for the correct number and another for the unit, as this is how you will be marked in your exam. It is easy to get confused. Remember that charge is the total amount, current is the rate of flow, and potential difference is energy per charge. Don't forget to convert minutes to seconds. This glossary outlines the key terms you need to know, from charge and current to potential difference and energy, along with their respective SI units like coulombs, amps, and volts. Everything is connected. Notice how charge sits at the heart of both major equations. Mastering the concept of charge is the key to unlocking the physics behind these circuit problems. You have covered all the essentials. Revise these terms, practice the calculations, and apply the 4-step method in your exams. Good luck! You are ready to succeed.